Here we have two reactions, and we're being asked to predict products, to complete the products. And as we can see, this is a diene furan that is a dienophile, and it has two electron withdrawing groups. Aldehydes, the reaction proceeds with heat, some heat, and this is another diene. And another dienophile, this time is an alkyne. So let's do the products. Again, the reaction is a 4+2 cycloaddition. These are examples of Diels Alder reactions. 4+2. So what are we doing then is we're moving electrons in a cyclic fashion. It is the cyclic transition state. So in these two arrows, I'm making two new sigma bonds, and we're forming the following structure. So here I have 6 carbons, 1, 2, 3, 4, 5, 6. This is a new double bond that I'm making, and oxygen here is not participating, so it's part of the bridge. And now I have these two groups pointing to the same side. And we need to keep in mind that this is also need to be kept here. And they will be then pointing to the same side. And the major product is the endo product. So these two groups facing down, opposite to that. So that's my product in that reaction. Let's look at the reaction below. The reaction below involves, again, 4 electrons here and 2 electrons here. So it's still a 4+2. So we're gonna keep we're gonna use only one of the 2 pi bonds, let's say, in that reaction. So again, we're gonna do the cyclic motion. So this is the electron movement. And again, in our product, we're gonna have 2, 4, 6. So we're gonna have a cycle of 6-member ring. I'm gonna start doing that. So these are the 6 electrons that were involved. So specifically, let's say I'm pointing dots here. The one that I'm using are the 6, which is the one that I drew. But I have these, there is a couple of carbons here that we did not use. So they're gonna be making a bridge. And now this bridge has 2 carbons, there's 2. So slightly different than the previous one that we did. And on the other side, I only use one of the pi bonds, so involving 2 electrons. So I still have another pi bond here, and I forgot to draw that pi bond here, right? Which we formed when we moved those electrons. So I'm gonna have double bond and double bond. All right, so next what we need to do is add the substituents. Now, notice that here this was sp, now it's sp2, sp, sp2. So I just need to draw those 2 carboxylic acid electron withdrawing groups. So again, what we need to do to predict products, we draw the molecules in such a way that we can form a cyclic transition state. We do the electron movement. Pay attention to the atoms that you're using. Here I have marked in blue circles. The atoms are actually participating and forming the cyclic structure, the 6-member ring under. And I'm highlighting in another color, a lighter color, the 2 carbon atoms that did not participate in the cycloaddition, and these are the 2 in the bridge. So it is another bicyclic structure, but it was different. Here I had used, the bridge had 1 atom, which was the oxygen. Here I have 2. And then I added the substituents. Keep in mind always that here you use one of the pi bonds, one of the 2 electrons of the 4 pi electrons, let's say, so you still have a pi bond in the product.